Buenos días. Good morning. Bienvenidos a la JCon Perú 2024. Welcome to JCon Perú 2024. Tengo el honor de presentar a Rustam Mandarov. Él es Java Champion, Google Developer Expert para Cloud y tenemos pues el honor de estar con él. Rustam is not only a Java Champion Google Developer Expert for Cloud, but also a highly respected engineer and community builder with extensive experience in IT architecture and integration. Welcome, Rustam. Thank you for your time and sharing your knowledge with our community.
Thank you very much, and thank you for introduction. Thank you for having me. Good morning, good evening, good afternoon, wherever you are. I mean, wherever I am, it's evening, and it's. But I wish I was in Peru. I wish I could join you in person because, I mean, for many reasons. But one of them, like kind of definitely one of the reasons is the community, and the other one is the weather. I mean, it's getting a little bit cold here now. It's like we're entering the winter time and all this, and it's not the same as what you guys are having over there, I think. But anyway, I mean, we're here now. We can just have some fun, and then we can talk about cloud native and Java and all those things.
Yeah. Okay. Remember, guys, the session or the talk is about your cloud native toolbox for Java. Okay. This is the stage is yours, Rustam.
Thank you very much. Thank you again, and welcome to everyone on the stream. And I would like to start with saying that I see the chat from the stream. It's right over there. So if you have any questions, any comments, please feel free to write them there, and I'll try to address them as fast as I can, or as fast as I see them. Most likely English is probably the best, but I do speak a tiny little bit of Spanish, like extremely little bit of Spanish. So you can try, and then if not, some of the organizers will probably help me to translate that as well. But okay, anyway, let's get started. So I would like to talk. This is a talk of what is cloud native for Java developers, and especially for Java developers, but also in general for developers. And also, what is cloud? What is cloud native, and what do we put into that kind of term? So it kind of all started with a little drawing that I started doodling some time ago. I think it was one of those Inktober challenges. During the October, you have the challenge where you draw things and everything. So I started drawing this little thing that you see on the screen now. It was the picture was called Confusion, and then I realized that I actually can build up on top of that and put it into my talk. So we'll start with a little bit of confusion on the screen, and a little bit confused and slightly sad, maybe a cat. What I ended up doing, I ended up putting a joke that you might have seen on the internet before, but if you haven't, well, that's the chance to see it for the first time. If you have, well, you'll see it in my kind of a version of it. So what is cloud? What clouds are actually made of? And it all started as a kind of legit question that kids can ask you as a parent or as a grown-up. What you answer might be different, might vary from the context and from your experiences as well. And in this case, it was, clouds are made of mostly Linux servers. There are some other servers as well, but it's mostly Linux servers. And then you can also talk about cloud native. You can talk about serverless and all this kind of things. And usually I like to start, or I like to show another thing, which is kind of another, relatively well-known joke out there, where it says, well, what, cloud is not the magical or special thing. It's just somebody else's computer. And I would like it for us to treat it this way as well, because like, when people talk about cloud native and cloud and serverless and all these kind of things, sometimes we tend to make it a bit more magical than what it is. And yes, it's magic because somebody else is managing a lot of those things for you, and you don't have to think about it, and you don't have to do like the data servers and data centers and all these kind of things. But at the end, it's a data center or it's something that you're renting out there. So from a bit of slightly bad jokes to a bit more serious matter. This is the actual official definition of cloud native, what it is. And it's made by CNCF, so Cloud Native Computing Foundation. And they have written this definition, and I think it's pretty good. But the only problem with that, it doesn't really fit very well on a slide, because it's just a wall of text, and now you all are reading it, and probably most likely lost, at least half of you, reading deep into this whole bunch of wall of text. And I tried to help you a little bit. So I tried to highlight some words. I tried to remove all the other words that are kind of filler words, and they're not really super important. I'll go back and forth just so you kind of see that I'm not removing anything of very, very important. So another thing I did was one more thing, and one more slide, is that I did remove the words, and now I tried to group them. So now we can talk about what. So what are we building? Well, we're building scalable applications that can run on public, private, and hybrid clouds. We're talking about how we do that. Well, we use containers, service mesh, microservices, immutable infrastructure, all these kind of things, right? And that's cool. What are we doing that? Well, how we're doing this. Okay, cool. But it's also very important to talk about why are we doing that, because conference-driven development is really good, and CV-driven development is also really good, because you're just picking technology and picking terms and all these kind of things because somebody at conference talked about it, or you want to have it on your CV, and then you just like work on a project. It's like, yes, now we can put containers on my CV, or microservices, or something like that. I mean, it's all fine, and and probably a good thing sometimes, but it's kind of interesting to understand why we're doing that. I mean, how it's going to help us, how it's different from the way we used to do applications back in the days when I started, when I was a junior developer, early 2000s, almost 20 something, well, getting close to 20 years now back. We still did Java, but it was a kind of different kind of Java. We would do monoliths. We would deploy them right onto our data centers. We would do it in a different manner. Now we're talking about cloud native, and all those things. So why? Well, because we want our applications to be loosely coupled. We want them to be resilient. We don't want like one little thing, one little error take down the whole application, or the whole a big chunk of your application, a big monolith, whatever you're having, right? You want to have a lot of automation, because you don't want to do it by hand and manually and all that. And you want to be able to respond to frequent changes. You want it to be predictable. You want to have less toil. So toil is a thing that we talk a lot about. And there is it's, well, if you try to describe it or explain it, it's kind of something that mundane tasks that we really need to do from day to day, and it's kind of boring, and after doing it a few times, you don't really want to do it, and it's not so exciting. And most likely when you do that, you will make some errors because you kind of get distracted, and you're not really motivated to do this kind of things. There are many reasons why it's probably not a good idea. So minimal toil is a thing. And if you look at this, actually, I don't have a slide on this, but I still want to mention it. So there is something called DORA, which is It's a DevOps. It's a research that it's a research group at Google that looks at how we developers work and how we can actually make our work and more our day-to-day life even better. So if you look at Dora research, and it's Dora.dev, if you go there and look at it, and they have like every year they do like surveys, they collect the data, they analyze it, they present it every year. And if you look at all those things that are there from the technology point, you will see a lot of the same things there as well. So it kind of makes sense on many levels, right? Okay, so we kind of dissected the definition, right? Now we know what we're building, how we're doing that, and why do we want to do that, right? So now we can actually try to go into more detail on each part of it. So the why, the last thing I talked about, it's very often can be described as business needs. It can be described as somebody coming to you and asking you, hey, I want you to create a new application and I want it to be like this, this, and this, and this, because. And then whatever comes after because, that's usually the business needs. Because, I mean, I've been working as a consultant for almost 20 years, and I've been working with very, very many different customers in different sectors and different projects, different businesses, everything was different. Like if it was government or public or private sector, if it was a big or small company, if it was in one field or another field and all that. And very often they would come to you and ask you kind of still very similar things. Those things are usually, they would be, if they're mature enough. I mean, most of the times they would be. Sometimes they might miss some of the points, but mature customers would also always very often come to you and ask, hey, you know what, we want speed. And I'm not talking about speed of your application or how fast your application is running, but I'm talking about speed it takes from an idea, from the way you start developing your stuff, or actually before you start developing, when you get an idea, that feature would be really, really great to have, all the way till that feature is in production. So that's kind of time to market thing we're talking about. And if you have very complex system, very complex, let's say monoliths, or just generally very complex architecture, it might take you some extra time, because now you have to not only just program your application and develop your stuff, but you also will need to figure out that really messy architecture, all the package structures and all these things that need to be satisfied to actually make it work. So, that's kind of sucks. And if you're a business and if you are very into this releasing new features and competing with having some competition and competitors in whatever field you are, then this part is very, very important for you. Another thing is kind of related, but a little bit different, but still it's quite related to the first one, is agility, in a sense of being able to respond to change. So that means like it's not agile as in a software development pattern or way of doing that or culture or anything. It's more about being able to change direction for your application, for your the way you do things and all that, and being able to respond to those changes, because priorities change, business needs change, your customers want something else, all these kind of things. And and by that you can also put a lot of things into there, right? It can be a lot about the architecture of applications and all this kind of things, but it can also be about the way you do stuff. Like, I don't know if you're doing feature branches or not. Maybe you're like, the way you create your commits and your branches will make you have to wait. It will force you to wait to be able to release some other features that were not planned, because you have already a bunch of commits that are not able to be pushed out to the public yet, and then you have to roll them back or something. It's if you're not really careful with the way you choose your infrastructure around your applications, that might be also a showstopper for that kind of agility I'm talking about. That was okay. Let's go back. Okay, let's go. Wrong button. So there is a right arrow on my keyboard, and there is an end button that is right next to the right button. So if you click on the red end button, it goes all the way to the end of the presentation, and that was a bit fast. So we'll get there, but not just yet. So okay, back where we were. Right, agility we talked about. So let's talk about the next thing. And next thing is reliability. That's another very important part. That's something that a lot of customers, and also you as a developer of your own application or your company's application, your product is also very, very big fan of, or should be a big fan of, is to create an application that is reliable, that the application is there when a user needs it. It means it's there available, but it means that it's available quite fast. So if you're using some kind of architecture, maybe serverless, maybe something like that, you might be interested in minimizing your response times. You might want to be able for that thing to scale automatically because you all of a sudden have a spike of users, or all of a sudden you have more popularity than you anticipated, and so you should be able to scale up and down. And also it's about availability in many ways. So availability can be something like close points of presence to if you have users from all around the world, but it can also be something like availability and being able to handle DDoS attacks and that kind of stuff. And if you split it up, and if you have some kind of architecture that lets you handle that in a nice way, that's also really nice. But it's also about things like that we developers sometimes tend not to think as much about it as we should. Things like testing, right? Because you want to make it reliable and create enough tests around it in one way or another, or just develop in a sense that it will be reliable, so you will not have unexpected bugs. Or, well, that's probably not the right thing to say. You will not have them, because probably you still will, but at least you will have less kind of less bugs than normal. Okay, next thing. I did it again. Guess what? Okay, I have to be very careful. Resilience. Resilience is kind of related again, but it's different. Resilience is not about being available for your users in that sense. It's more about being able to handle unexpected things as errors, as being able to provide information to whatever you're using on how your application is doing. So it's being able to withstand some kind of attacks and that kind of things as well. So fault tolerance, that's kind of what do. What you have monoliths, or even you have a bunch of really super modern cool microservices, or even simpler, you have a simple application that is calling another API somewhere out there on the internet. How do you handle errors? Like that thing that you're calling is down. What do? Do you just like crash and fall and just show a big 500 or a stack trace or something for your users? Or do you actually try to do it more gracefully, maybe just showing a little error as a tiny little part of your application, saying, hey, you know what, the rest is working, but this little thing is not working because something is down? Or maybe you actually even have a fallbacks to another application or to another endpoint that is a bit less precise, maybe less reliable, maybe a bit slower, but it's still there when something else is failing. Also, do you have things like retries? Do you want to you do want to have retries, and you do want to have things like backoffs, so when you're retrying, you don't want to keep retrying really, really fast all the time. You want to do it for a little bit of time, and if there is no time, you do exponential backoffs of retries as well. So all those kind of things I put into this resilience box, and that is something very, very important to keep your users, to improve your user experience and to improve your quality or perceived quality of your application, right? And there is one more thing that usually customers ask a lot about and talk about a lot about and very often misunderstand. It is this thing called lock-in. Sometimes they would just say, you know what, we cannot choose a product, a cloud provider, a even language or library or something, because like, no, we can't use that. We you know, it's going to be a lock-in for us, and we don't want to do that. This is not how we do things. And they would just force you to make really strange choices sometimes. The kind of the most extreme case I've seen, or well, not probably the most extreme, but at least one of the kind of unfortunate cases I've seen is when a customer didn't really want to use a managed database, SQL or relational database managed by a cloud provider, saying, hey, no, we cannot use that, even though it's totally standard, absolutely standard Postgres, MySQL, something very, very standard installation or interface, but we cannot use it because it's a managed one. So we have to use. We're afraid that we'll be locked in on that cloud provider, and then we would rather want you to create a VM, install operating system on it, install database on it, and then like let it run as a separate standalone thing on a cloud. And that's like, you know, that's not the lock-in we're talking about. We're talking about lock-in of using a proprietary kind of very specific applications that might give you a headache moving, or if you have to move. And then, so there is a lot of things that you need to think about. Is like, one of them is like, what kind of lock-in are we getting? Where do you want to have a separation of the, where do you actually consider a thing to be a lock-in? Like, for example, if you're starting to use, if you decide to use Java as a language, or Kotlin or Go or something, if you start using a specific language, is that a lock-in? Is it a lock-in if you decide to use a specific library? Is it a lock-in if you decide to use a specific build tool? All those things technically can be classified as lock-in, depending on where do you want to put your limits and what you actually call a lock-in. To me, it usually means very, very specific applications that cannot be, or offerings that cannot be ported easily, which will probably very often mean a total rewrite of at least parts or a whole application very often. So usually if you use open standards and all this kind of things, you will be fine. If you're using open standards, open APIs, in a sense of APIs that are public or APIs that are common between different products, you will be fine. You will be not locked in most of the times. So that's the why, right? The what, I'm going to go real quick through this because we have probably heard quite a lot about that already, so no need to spend too much time on this. So we're building our scalable applications that can be deployed on public, private, hybrid clouds. So what is this thing? Well, cloud, it can be public or private. So public providers, so there are quite a few of them. There are a few big ones like Google Cloud, Azure for Microsoft, AWS, all this kind of things. There are a bit smaller providers of public clouds as well. And there is also private cloud, which means that you build your own cloud offering for your own needs, for your own users, and all this kind of things that are not open to kind of general public. Another thing is like multi-cloud, which most of the times normally means different providers. So you're kind of mixing different providers. It can be many reasons for that. It can be, for example, availability of features. So one cloud has a better something, the other cloud has better something else. and then you just pick and choose whatever is good. It can also be a different thing. It can also be, for example, that your application is so important that you really need to actually have a good failover, and you don't really, it's so important for you and so critical that it's not even enough to use all the availabilities and zones and regions and all that cloud providers provide. You really need to be sure that it's always available, so you actually use different cloud providers to do like failovers and all these kind of things. It can be just simple as pricing. It's like some products are cheaper in one cloud and then some others are cheaper in the other one, so that kind of things as well. And then there is the last one, which is a hybrid, which is kind of important to mention here as well. That's typically a public or private or whatever cloud combined with your own on-prem servers. So the little stack of things that you see on the screen, that's actually supposed to kind of show a rack of servers. So you have your own data center stuff there as well. Reasons for that can also be, again, very different. Sometimes can be very specific hardware requirements, like, I don't know, you're using very specific kind of hardware that's not available for on public clouds maybe. Or it can be something like privacy. So like in Europe, we have a lot of regulations that don't let you put certain kinds of data out into public clouds or out into clouds or data centers that are not within EU or something like that. That would typically mean that you will maybe need to do some hybrid cloud kind of stuff where you store your data locally, you put it into cloud, getting processed, do something with it, and then you put it back into and store it in your on-prem solutions. It can also be combined with a lot of security, encryption, bring your own encryption keys and all this kind of thing, so nobody on the cloud can actually see your data or see it being processed, and like secure instances and all this kind of things, right? Anyway, that's the kind of the short version of cloud, multi-cloud, and hybrid clouds, what that actually means. Right. So that's the most important thing now. That is kind of the toolbox that I've been promising you for this talk, and this is the how part. So we have understood like what we're doing, how we're doing it, and everything. Now let's talk about the tools that can actually help us to get this through this. And the how is, well, as you can see up in the corner, I clipped out the how part from our definition that we saw earlier. It's about containers, service meshes, microservices, immutable infrastructure, declarative APIs, and all that. So one of the things that we talk a lot about, and we have to talk really about when we talk about microservices and containers and all that, is loose coupling. Because now all of a sudden, instead of having one big monolith with a lot of spaghetti dependencies in there, now you have to have loose coupling, because now you have many more services that really need to communicate over something, and that something would normally be some kind of APIs. So now you have to think about designing your APIs properly. Now you have to think about how that communication should go through. Is it RESTful APIs? Is it gRPC? Is it like, what kind of standards and formats are we using? Are we talking about? Now, since everything is going over HTTP most likely, then you can also, you will have to think about things like service mesh, because now you need to protect the traffic, and you need to do encryption of your traffic, and you need to have most likely sidecars and all these kind of things for your containers that will do SSL encryption and all these things, right? So there's a lot of things that you need to start thinking, because it's not just like a silver bullet that may make your life easier. It will, but it will also make it a bit harder, because now you have to think about all those things, about designing your services, designing your proper architecture, much better architecture than a monolith where we could just like throw things in and just like pretend it's amazing. It's also about doing things like designing proper good APIs and deciding how they will be looking like. How do you version those? How do you, when you deploy and roll out new versions of your applications, how the APIs will be changing and how those changes will look for users. Right now you have to do versioning, for example. Are you doing through path? Are you doing it through headers? All those kind of things. Right. Another thing as well, obviously, is containers, right? It's like you cannot talk about microservices and all that without mentioning containers. Containers have been there for a while. We know what it is. What I usually like to underline here, which is kind of important thing to keep in mind, is that containers is very often you just don't think much about why we're doing this. But to me, and probably to you, it also should be predictability, and predictability in many ways, and actually at least two ways. So predictability of your builds, so if it builds on your machine, it will most likely build on your colleague's machine. And it's also about predictability of deployment. So you know that if it is built and being able to deploy it one place, it most likely will work and will be able to be built and deployed somewhere else. There are a few gotchas. There is the thing of architecture and CPU architecture and all this kind of thing. But there are ways of working around that as well. So you can build like multi-architecture containers and all this kind of things. But it's about predictable builds, predictable deployments, and it's about portability. So knowing that, my application is running on this solution, let's say, for example, Kubernetes, but it's a container, it's a kind of it's self-contained kind of thing. And if I don't like this Kubernetes instance, I can move it to another one, or if I don't like that, I can move it to a serverless or something like that, where I can bring my own container. So that helps us with a lot of lock-in issues that we've been talking. That's why you see the little unlocked lock thing at the bottom there. Another thing that we need to do with all this, because now we're having many more containers, many more deployments, many more all those kind of things happening. Now we need to automate much more. If we had to automate with the way we used to do before, we have to automate even more now. And it's different reasons for that. One of them, obviously, is that we don't want to do boring stuff. We just want to do it, let computers do that. Computers are really good at doing boring stuff, so you can do that. But it also will save you time as a developer. It will make your applications less error prone, because whether you like it or not, we developers do make errors, and then we will make something do something wrong, do some kind of error, and it will influence and have some issues in our applications at the end. And also, it reduces toil, this thing that we talked about, like reducing the boring parts, and then you can actually spend time doing actually fun things, writing code, creating new bugs, all this kind of things. Well, features, sorry. Yeah. Anyway, bad joke there. Okay, resilience. We would like to talk about quite a bit about the resilience, how to make your applications resilient. We talked about that a bit already. So fault tolerance, observability, security, all these kind of things. Okay, how can Java developers ensure scalability when designing cloud-native solutions? Good questions, Carlos. We'll get there. Next slide, I promise. There will be a lot of scalability and all these kind of things. So keep asking questions. That's great. I see your questions there. It's right there. So I can see them. So keep asking them, and I'll read them out loud as I see them. All right. Last thing is scaling. It used to be different. I used to call that last point for serverless. I did change that because I really wanted to talk about more than just serverless, and I just wanted to talk about how to scale the things. We want for our application to be more scalable. That's exactly the question that Carlos asked, right? We want it to have an automatic scaling. We want to look at things like serverless. We want to reduce cost of our applications, running our applications. So, for example, idling applications that's not being used and all that. And also reduce reduce toil. So less toil, and that little drawing you see at the bottom there, that's my way of trying to draw money. So you can think of it to yourself. It's paper money, plastic money, whatever you think it is. That was my way of trying to draw something related to money. There's another question from Carlos. What do you think AI or machine learning could play? What role do you think AI or machine learning could play in the future of cloud native development in Java? Yeah, that's going to be interesting. Well, we'll see. I'll see if I can talk a little bit about cloud native as well. Sorry, cloud native and AI. That's what I meant. Okay. So tools, the toolbox. Let's go through that. So loose coupling, right? We've seen all those 5 things here. We're going to do the same 5 things with some tools. Loose coupling, well, it's all about creating your application, creating your designing your application, your architecture of your application, but also creating your microservices and all that. So you can do things like PMD, JDEPs, and all that to build your application, to make sure that your application is, to visualizing and showing dependencies and when you need to split them. There are things like Kiali and Istio that will help you to separate and run all those things as a service. And Kiali is kind of really cool console for Istio. So it can actually show you a lot of things. It can show you topology, health, tracing, validations, wizard, all those kind of things. That's really, really useful kind of tool. Istio is a service mesh. There are a bunch of other service meshes. We'll mention them in a little bit again. There are some other things that can, it doesn't matter. I'm not really trying. I'm trying to pick up some open source tools that doesn't cost you money, and they can also help you with, oh yeah, that's another good question. How much does the GraalVM application affect deploy time? For example, when you have to solve an urgent critical bug? That's really, really good question, and it's really cool. I have another talk where I actually talk about this kind of things. It does, GraalVM can actually help you a lot with both making it fast to run, making it very fast to start up, but it also might need a bit more resources to build. So depending on your build strategy and deployment strategy, it might be very, very good. And sometimes it might need, you might need to rethink your strategy if you are doing too many builds too often and you're paying for build minutes or paying for your infrastructure by number of resources and all these kind of things, because it might take a bit more resources than building kind of JVM based applications. And with GraalVM, I'm assuming you're talking about native images. So that's a really good question as well. Okay, let's go to the next point. Containers. Well, there are different ways of putting containers. There are different ways of deploying things. It's still the same kind of OCI standard containers. But there is tools like Docker, there is a Podman, there is Rancher, all Kubernetes, obviously, K9s. So it's a bit of a kind of fun tool to run Kubernetes things. There are also all this mini Kubernetes instances, or like mini cubes and all this kind of things. And of course, we need to think about where do you want to run it, how do you want to run it, which product you want to use for this and this kind of things. And most of them will have like a free open version, and some of them might ask you to pay for some things. But you have to think about that, and what do you want to do? Do you want to deploy our containers on the serverless platform, or do you want to deploy services on something like Kubernetes that's there, or you want to do something, for example, serverless? We'll talk about a bit in a bit, but I'm still going to mention like something like Knative and things like that. And when you put containers, you need to think about service mesh. So 2 examples of service meshes is Istio that we mentioned already. Linkerd is another one, and there are a bunch of other service meshes as well that are more or less complex than Istio, maybe. That's the one that we heard probably most often and most about. But yeah, so now you have to think about all this. There is a bunch of other tools. And by the way, if I'm mentioning some tools or not mentioning some tools, and you have some comments, feel free to put them also in the chat. Right, automation. Well, that is a fun thing. So we can automate a lot of things. We can automate builds. So, we can also automate deployments. We can also automate things just compiling our code. So, with compiling and building our code, well, then we have Maven, Gradle. I don't know if you really want to go that way. You technically also have things like Ant and stuff like that. I'm not judging, but it's still kind of automation, I guess. But most of the times you will end up with something like Maven or Gradle, right, in the Java world. With build tools, well, again, like depending on on your needs and how your things are put together, you might end up with using something that is provided by cloud providers, like, for example, Cloud Build is on Google Cloud, GitHub Actions in GitHub world of all this GitHub related stuff, and Azure and all this. You have things like, if you want to go on-prem, or if you need to create some special something, maybe it's things like Jenkins, cloud providers like Circle CI. There's a bunch of other ways of building your stuff and deploying things like Argo CD and all this. But doesn't matter what. The point is here is that you need to automate, and you need to pick some of those tools. And if, again, I'm going to mention it again, if you have some comments, if you have some ideas, feel free to add, and I'll comment on those as well. If some tools that your favorite tools that I'm not mentioning, for example, or some of the tools that you don't really like, I don't know, Jenkins is too old school. Well, maybe it is. Maybe you need to have it. Depends, right? I've heard all this kind of opinions before, or a lot of them anyway. So resilience. Resilience is kind of a fun thing. So most of the things in Java related to resilience will be based on the implementation of resilience4j, or importing resilience4j and doing something about it. There is something provided by a spec by Microprofile. There is something by Spring Cloud or Spring People. It's all about failovers and being able to create retries and failovers and all this kind of things for endpoints that might not be responding as you expect them to do right now or at the moment. There is also it's all about also way of showing how your things are put together. So things like OpenTelemetry, Micrometer, Jaeger, Prometheus, all this Grafana, Loki, Tempo, alerting, all these kind of things of collecting and making data about your application available, and collecting it, and also visualizing it, and acting on it. The resilience is also about security. So there are things of like security scans, static code analysis, things like SonarQube and all this. Managing secrets. Don't put your secrets into your microservices and inside your containers. You might want to rethink that kind of thing. It's also about resilience, because if those get exposed, then you have a problem. There's also things like secure software life cycles, and all these things of dependencies, and managing dependencies, managing known vulnerabilities of your dependencies and all that. And at the end, there is this thing called scaling. Well, scaling is, like I said, it's kind of partially about being able to scale up and down. A lot of things that we talked about already, like Kubernetes and Knative and all that, will provide scaling for you based on some parameters that you provide. It can be like number of users, number of memory used, or CPU percentage, and all these kind of things. And based on that, you can create scaling up or scaling down your application strategies. And there is something called Keta. There is a Cloud Run, and there is also things like Azure Container Apps, where you can bring your own container and deploy it there. So Google Cloud Run, that's basically more or less a managed version of Knative. And Container Apps is a kind of a similar thing on Azure. And there are ways of deploying your bring your own container kind of thing. There are ways of also doing a bit more serverless functions and all these kind of things, but I'm not mentioning it here really, because we're talking about here about like a containerized separate applications as well. I think I'm kind of starting to run out of time, but I'm still looking at the chat if there will be any other questions. And so AI and machine learning what role do you think AI and machine learning could play in the future of cloud native development for Java? I think it will make it. I think it will make some things easier, but we'll also still need to think about exactly the same way as we have to think where we deploy our applications on. Do you want to do serverless? Do you want like Knative or something? Do you want to go Kubernetes? Do you want to go like a VM? Or do you want to go on-prem? You really need to think about it. And the same thing is with AI. We don't really need to try to solve problems that are not there or can be solved in other way by just AI, because everybody talks about AI. But AI has a lot of power, and it can do a lot of really, really cool things. And there is a lot of things, like if you really want to look into AI and Java and all this kind of things. So there is LangChain for J, for example, that I would advise you to have a look at if you haven't. It's really, really interesting. It lets you combine large language models that are hosted with local large language models and do all this kind of interesting things, putting it all together. So LangChain for J, if you haven't looked at that yet. And there's also, have a look at a bunch of open language models, LLMs out there that you can actually download and play around with, and maybe it can actually improve quality of your application depending on the use case and all this kind of things. Any more questions? While I'm still waiting for your all questions, is that, one more thing I should mention when it comes to that was Andres has a question about GraalVM. I think I already addressed that. Okay, how much does GraalVM compilation affects deploy time? No, well, oh no, actually, that's a good question as well. So GraalVM compilation deploy time is fine. I mean, deploy time, you just deploy your container. It's the build time that might be different. And also one more thing that you need to think about is that if you deploy as a native application, you do not have a JVM anymore. So you will not have some optimizations and garbage collection, all those kind of things that JVM, whatever build of OpenJDK you have, whatever distribution you have, has some kind of smartness inside there to do some optimizations. You might not have those if you're just compiling everything down to native binary images. Solving an urgent critical bug, well, it might take a little bit longer to compile your application, but I don't think that will influence it too much. I think if it takes like 2 minutes to build or 5 minutes to build, it's probably not very big difference. But it might influence. Yeah, I think you're good. I don't think on this will gonna influence too much on this side. But I'm happy to talk more about that. If you have some more questions, feel free to ping me on any social media or anything, and we can talk about that. So I did write a few things about that are kind of related to what we talked about. Some stuff about security, so some security principles for cloud development. That's an interesting thing to have a look at in 2 parts. It's also another talk where I'm talking about fault tolerance metrics, health, feature toggling, and all this kind of things, showing an example of microprofile. So that is another talk, but it's also a repository that you can actually have a look at and compile yourself and build it. It should say everything there on a README file, so you can actually build and have a look how it's done. And you can probably see something very, very similar for other Micronaut, Spring Boot, and all the other ones as well. But mine is based on Jakarta EE and microprofile. And the other thing is that it's also about another piece of code where I'm actually showing a very simple example, but I'm also showing it how to deploy in different builds in different ways to the cloud, and also what kind of optimizations can be applied to it. One of them is GraalVM, so I talk quite a bit about GraalVM and all that. It is a talk, but it's also a repository where you can actually have a look at all those kind of things. And if you want to have a video of those talks, ping me on social media, and I'll send you a link to one of the conferences where I've done this before. Speaking of social media, so this is so I created one website where I put all the links to all my accounts. That's rustam.no, and go there or scan the QR code that you see on the screen. It will bring you to that rustam.no site, where it's basically a list of links to all my social media. It's Blue Sky and X or Twitter or whatever you want to call that, Mastodon, all the other ones as well, and also my GitHub as well, where you can find all those things. Thank you all for having me, and thank you all for really great questions. And oh wait, there is one more question. Do we have time for one more question? Yes, thank you. So Frank is asking about what resources or communities do you recommend for Java developers to stay updated on cloud native trends? I would say start with your local jugs. Java user groups are really good. Depending on where you're based, there will be another really nice conference and events like this one, the one you're here as well, JCon. And there is also another one called DevNexus in the US, and there are a bunch of really nice events in Europe as well. So if you're not sure which ones they are, again, try to ping me and I'll try to find some events near you as well. My messages my DMs are open in most of the social media as well. So feel free to ping me and I'll be happy to discuss, or even do it publicly. Just add me in one of those. Most of the times I'm most active on Blue Sky nowadays, but other works as well. All right, I think I am very much out of time now, and it's been really, really fun talking to you. And thank you for being so active and asking questions, and thank you for having me, Jose, again. And it's been a great pleasure.
Muchas gracias, chicos, por su participación. Thank you very much, guys, for your participation. Rustam, thank you so much for your valuable support and for sharing your expertise with us today. Your insights are truly inspiring, and we deeply appreciate your contribution to our conference. We hope to see you again soon, whether in another event or perhaps in Lima, Peru, where we love
I would love to. I mean,
you need to experience our incredible gastronomy. You are always welcome.
I'm so looking forward to that already. So let's plan something.
Okay, my friend. Thank you. Take care. See you again.
Bye,
chicos. Nos vemos en la siguiente charla. Gracias a todos. Gracias, Rustam.
Gracias a todos.
Bye, bye.